Is the screen visible?
Yeah.
Okay. So today I'll be doing query processing for y'all. Then query processing agattut, it's like a lesson which has to be done for 3 hours odd. So then I have only 1.5 hours. So within that time, I'll give you all the core knowledge that you need. Then ඒක අරගෙන ඔයගොල්ලෝ මේ තව පොඩ්ඩක් refer කරගෙන එම just to brush up your knowledge, I'll be doing some parts. We'll start. Because there are some connection issues and all. Monari may, if you can't hear me, Tagala drop a message so that I'll do something for it. Okay, so first I'll give an introduction about query processing. Then මෙතන අපි බලන්න යන්නේ, this is the process we are going to see. Now, when we write a query initially, there are 3 steps happening when a query is getting processed. Okay, so the first step is parsing and translation, then optimization, and then evaluation. Then, parsing when you pass a query, the parser will check if your syntax is correct. Then, queries so if you have select from where, if there is any error and stuff, you get that error because of the parser. So initially your syntax has to be correct. If your syntax is correct, this query will be translated into a relational algebra expression. So that is done by the translator. Then query if it has to come to a relational algebra expression, there are various ways where you can write a relational algebra expression. Okay, but every way is not efficient. Then one expression ge cost එක වෙනස් තව එකකින් බලද්දි. So the next step what the optimizer does is it will see a lot of plans and choose the best plan. Best plan කියද්දි the best plan should have lesser number of input output. That means using that plan, the read and write cost must be less. So if it is less, that means the resources used by the database will be less. Then resources used කරන්නේ less na අපිට වැඩ ඉවර කරගන්න පුළුවන් time එක අඩුයි. So that's the reason you need an optimizer. Right, so first step what you all have to know is how to convert a query into a relational algebra expression such that you have lesser number of IO costs. That's the first task. So we'll go and take a look at an example. Okay, so yes, so this query. Now if you see this query, select from, there are 2 tables, S and SP. And there's a condition, may SP table P number P2 people only can be selected, and then you have a join condition. So to write this query, we have various ways. So this is one example. Okay, so initially you can join the S and SP table. Then නිකන් හිතමු S table එකේ there are 100 records. And SP table එකේ තියෙන්නේ 10,000 records. Okay, just assume so. So if there's a Cartesian product, ඒකේ idea එක වෙන්නේ මෙහෙම. Now S and SP tables are there. You have records in S and you have records in SP. This is the idea. If it's a Cartesian product, වෙන්නේ එක මෙහෙම. Take the first record of S, multiply with SP. Take the first record of S, multiply with SP second record. Mehema, every record is getting multiplied. Then if this record is over, it goes to the second record, then it will multiply with this. So when it comes to a Cartesian product, when this is over, you will get this much of records. Okay, 100 into 10,000 records are there here. Now the buffer does not have enough space to have these records. So what happens? These records are again written to the disk. So now initially to read from S and SP, you have this much of read IO. So initially this is this much of 100,000 IO. Then because the buffer can't have all this, what I'm doing, I'm writing this back to the disk. Then write cost එක කෙනවා තව 100,000 IO. This is the second writing cost. Now my next step is I have to evaluate this condition. That means from these 100,000 records, P number P2 තියන records ටික මම ගන්න ඕනේ. But to get it, now I don't have anything in the memory. Everything is there in the disk. So now again I'm reading all these records from the disk. So what is happening? Initially to read these two I have 100,000 IO. I'm writing those to the disk, so 100,000 IO. Then from the disk I'm reading it again 100,000 IO. Then only I'm performing this thing. Okay, so the cost here is 3 times 100,000 IO. So that is what is mentioned in this place. Okay, when it comes to Cartesian product, that is what happens. Now for a change, let's change the expression a bit and see. Okay, so let me show that. So now let's evaluate this expression. Now here what happens is, again say this has 100 pages and SP has 10,000 pages. Okay, so initially it's 100 and I'm reading SP, that is 10,000. Now once I read that, metanama I have the condition. So I'm evaluating that condition. Then කියමු P2 satisfy when a condition like 50 කියලා. So now the only 50 records are satisfying this condition. Okay, so that amount of records can be there in the buffer. So that's possible to have, no? So I එක ගිහිල්ලා hard disk එකට we don't need to write it. So what happens here is we are only reading this 100 times, this 10,000 times, and we are evaluating this condition. That is all what's happening. So our IO cost is this much only. Before it was 3 times of this. But the difference is here both are having the same output, but ඒකේ මේ DBMS එකේ ඇතුලේ වෙන දේවල් is different. Okay, so that you have to understand. So even for the IT people and DSDA, both your past papers, you all are having questions to write appropriate relational algebra expressions. Okay, so now since it's an MCQ and a structure, for structure, because we can't draw all these and show, maybe you can get MCQs to then query එකක් දීලා මේකට choose the best query, the relational algebra query. You can choose like that. There can be questions like, okay, so this expression is called a query tree. So to know how to write this properly, there are certain set of rules. Okay, so I will explain those rules first. Give me a minute. Can you see my screen? There's a PDF. You can see, right? Okay, so there are some rules that you have to know before writing a proper query tree. Okay, so the first rule is conjunctive selection operation. Okay, so here what happens is then for an example, think we have to choose from an employee table where the age is 10 and the department is engineering. So normally අපි query එකක් ලියද්දි කොහොමද ලියන්නේ? From select name from employee where the age is 10 and department is engineering. That's how we write the query now. But for efficiency, if we can do it like this, then මෙහෙම එකපාර දෙකම select කරන්න නැතුව we can select one column and then from that selection you can select the other column. Now I'll give an example. Now same example, we are going to select records where age is 20 and department is engineering. කියමු age is 20 records, there are 10 people and department is engineering කියන එක there are 5 records. Okay, so if I get this first condition as department is equal to engineering, then metanama from 100 records I'm going to only get 5 records. Then the next condition will evaluate from 5 records. 5 එකෙන් බලනවා age එක 20 කවුද කියලා. දැන් හිතලා බලුවොත් බලන්න දැන් initially if you take 20 records and 20 එකෙන් බලන එක ලේසිද නැත්නම් 5 records වලින් බලන එක ලේසිද? So obviously seeing from a small amount of records another condition, if you want to check another condition, that's easy. And so the read cost is also less. So this rule, what we have to do is, if you have two or more conditions, our condition එක බලන්න ඕනේ which condition will give you lesser number of records. Okay, so that condition will be done first. I'll repeat again. So say Department of Engineering, there are 20 people, and age there are 30 people. So first you filter the Department of Engineering. 100 people in the 20. Take the Department of Engineering people who are 20. Then say from that 20 you can take the age from that department equals engineering. Then you can get the age as 20. So that time is less. So that is one rule. Okay, if you don't get anything, please drop a message. Okay, I will explain it again. So that is one rule. Now, without evaluating both conditions together, that takes time. You can do one after the other. Then one after the other karati, there is no difference in your output. Okay, now Komat, you're going to get the department engineering and age 20. That is the final one. But if you choose the table which gives that means the condition which gives the lesser records first, then the next part will be done quickly. So that is selection of commutative, and first one is conjunctive selection operation. Now since it's an MCQ, you have to know the concept as well as the name. Maybe there can be MCQs to ask what are the equivalence rules. නැත්නම් මේක දීලා what is this rule කියලා අහන්නත් පුළුවන්. So first you know the concept, and then again just have a look at the name. So one thing is you have to evaluate the conditions alone, and the second one is the record which gives the lesser the condition which gives the lesser number of records. Take it first and then go for the next one. So that will increase the time. ඒ කියන්නේ IO එක අඩු වෙනවා, so the time taken for your query is less. So users will finish the query with higher speed. That's the idea. Then this is just a natural one. You get only the outermost projection. I will explain that with a question. The next one is selections combined with Cartesian product and theta joins. Now before I showed you an example where S Cartesian products SP. දැන් මෙහෙම තියද්දී S and SP වලට condition එකක් නෑනේ. You don't have a condition. ඒ කියන්නේ S number equals if S number of S and S number of SP equal වුණා විතරක් තමයි මේක ගන්න ඕනේ කියලා there's no condition. So when you have a Cartesian product, it will multiply every record of one table with every other record. එතකොට නිකන් there is more number of IO which is a waste. So normally the best practice is without using a Cartesian product, you use a equity join with a condition. So if you have a condition, say choose the records where S number of S table is equal to the S number of SP table, then it won't select everything. It will just go and look, but it won't take it if the condition does not satisfy. So the best thing to do is, without using Cartesian product, use Cartesian product with theta joins. That means with a condition. That is the fourth one. So I will show this with the question itself. Now we'll go for our tude. In our tude, there is a question about the relational algebra expression. This was a past paper for the IT students, the paper. Okay, so hope you can see that. Now let's see. I'll just tell you how to start, what to select and how to start. So say you have this table sailors, boats and research. The first thing that you have to see from which tables they are selecting. Okay, so they are selecting from sailors, research and boats. Then the second thing what you have to see is now join. මේව දැක්ක ගම you know these are join conditions. S.SID is equal to R.SID, R.BID is equal to B. මේව ඔක්කොම join conditions කියලා දන්නවනේ. අර join conditions නැතුව අනිත් conditions ටික බලන්න. So you have one extra condition is B color is equal to red. Okay, then once you find a condition like this, see from which table that condition is coming. Okay, so color is coming from boats table. Okay, so choose that table first for your answer. First what we have to do is take from boats table, take the color, Wait, let me show that to you as well. So here the question is create the relational algebra expression and give a graphical representation. So first we'll write the expression and then we'll give the graphical representation. Yes, hope you can see my screen now. So as I said, first find the condition. Joint condition is nattu තියෙන අනිත් condition එක බලන්න. And then see අර condition එක තියෙන attribute එක which from which table it is coming from. So it's coming from both. So take both first and filter the red. Now imagine you have 1,000 records and AK red color තියෙන records ටික අපිට 300 කියලා. So when you do this first from 1,000 only 300. දැන් මෙතන වැඩේ ලේසිනේ මෙතන 300 records වලට විතරයි join වෙන්න ඕනේ. You don't need to have 1,000. දැන් නිකන් හිතලා බලන්න you are joining boats and reserve first. එතකොට there you are getting 1,000 and then you are joining reserve and sailors with a condition. So because it's with a condition you have 1,000. From that 1,000 you are getting this boat which is 300. So that is a waste, no? So first you take 300, that's what the lesser number of records first, and from that you are doing all the conditions. This is the idea that you have to take to your mind when drawing that relational algebra, the query tree and the expression. So hope you got it. So this is the expression, and then once you write the expression, drawing it is very easy. You have the board table. Let's go to board table first. And board taking we are filtering the color red. Then here we have only 300 records because color red is equal to 300 records. Then with that 300 records, join the other records and then join the other records. So here when you see comparatively the IO cost is less. And imagine if I have used the Cartesian product here. Cartesian, if I had put everything will join with everything, so that will take a lot of time. So but now here I don't have a Cartesian, I have a Cartesian with theta join. I have a join, so only which satisfies this condition will be fulfilled. Okay, so this idea you should have when choosing a expression. Then MCQs will have to think they have given a query. The first thing you have to see is this additional condition and from which table, and then from that table you start from the left. Finish the filtering first, that means the select where conditions, finish it first and then join it later. That is the idea here. Yes, so hope you got it. Let me go back to the slide again. So the rules that I taught now, that is called the heuristic rules. Okay, so for that you have particular names. You should know what names are those, but the basic idea is that. So the main important heuristic rule is that you have to do a condition first before doing a cross join. Okay, that's the basic idea. So in a structured paper you can have questions like why a selection is important than a join. That means why do we do the selection first before the join? So that for that part you have to explain this. Again, you have to relate the IO cost, read write, the time that it takes. එතකොට time එක අඩුයි, read write එක අඩුයි. එතකොට අපේ query එක fast. That part only explain. It is a once that is done, that is the optimizer's work. Then optimizer will do is it will evaluate all the relational algebra expressions and find the cost. Again, lesser IO cost. If you have lesser IO cost means the idea is the read write is less. So read write is less means wait, let me write it. If the IO cost is less, the read write is less. If the read write is less, the resources used are less. Resources used are less. So if the resources used are less, the time taken for this query processing is less, which means your query processing is fast. That's the ultimate idea of optimization. So in the DSDF, there was a past paper question asking why optimization is important. For that, you have to explain this one. You have to say if the query tree is optimized, that the IO cost is less, IO cost is less now, read write is less. If the read write is less, DBMS will use, the database will use lesser number of resources, and cost if the read write is less means the time is less. එතකොට අපේ query එක process වෙන්නේ fast. So the basic idea of optimizers is we want a query to perform fast. So that is what is happening in this. So the next one is when estimating the costs, there are certain algorithms used. Okay, so each algorithm can give you different types of cost. So we'll go to that part now. So there is another question also which I came across. What are the joining algorithms? That means what are the join algorithms used? In that you have many algorithms. What we are studying is simple nested loop join, page oriented nested loop join, block nested loop join, and index nested loop join, and sort merge join. So those ones now we will see how to do it. Now, simple nested loop join that means there are particular theories which you have to remember. Okay, but then there are equations. You don't need to memorize the equation if you understand what is happening. Okay, so I will explain what is happening. Let me go to the PDF which I have. Okay, so hope you can see it now. In a simple nested loop join, when you have an outer table and an inner table. Okay, so I have taken the outer table as R and the inner table as S. From the outer table, each record of the outer table is scanned with the inner table. That is what happens in a simple nested loop join. Take a record from the outer table, and for each record you have to compare the inner table. Okay, so we'll write a cost equation for this. Now we have a lot of records. Then record is the smallest unit, no? Our records තියන්නේ pages ඇතුලේ. So think m number of pages are there here. That means there is a page. Inside that page you have records. There is a page. Inside that page you have records. Eventually, when you're reading all the records, you will realize you have taken all the pages of the outer table. Then මෙතන pages ගාන m නේ. So you have m number of pages inside the cost. Then records eking එක to read. Finally බලද්දී you have read every pages. So එකයි this m has come. Plus for every record you are reading the inner table page. So inner table will say there are n number of pages. So for every record, no. So there are m number of pages, and if the record is PR, you have m into PR number of records. So this much of records are read by the inner table. So this is how this cost comes. Okay. So let me just show it here as well. There are m number of pages. Okay, this is the outer table, and there are n number of pages here. In a simple nested loop join, what happens is for each record we are reading the inner table, the page. For each record we are reading the inner page. Okay, so here there are this much. Then when you're going to read this record, this record, this record, this record, you have read the whole page. Likewise, at the end you will read all the pages. That's why we have put m number of pages. And then you are reading the inner pages for how many times? How many records you have? That much of times you are reading the inner table. That is only m into PR. This much of times you are reading the inner table. Okay, that is the idea of a simple nested loop join. Like pay attention to this because there can be structured questions. There was one question where I had to differentiate simple nested loop join, page oriented nested loop join, and block nested loop join. So for that, this idea is important. In a simple nested loop join, we are going to take only a record. That idea is important. Okay, so the next one is a page-oriented nested loop join. The name itself tells that we are going to compare the whole page here. Now initially we compared a record, then ganne page ekama. Okay, so take one page from the outer table and read the inner page. Take one page from the outer table and read the inner page. That's how it happens. So ultimately then pages okkoma gannawani meke. So we are reading m number of pages, plus for each page we are reading it n number of times. That is only page oriented nested loop join. So simple nested loop join is we are taking record by record. This is the difference. And in page oriented nested loop join, we are taking page by page. So if they ask you to compare, you have to compare it like that. Then the next one is block nested loop join. I'll show it. Block nested loop join. So say there is the same table here, M and N, and you have buffer. This is the buffer, and say they have given the buffer frames that you have is B. Okay, so the buffer frames you have is B. Once they give the buffer size, you have to know there are 2 buffer pages already allocated for another purpose. The rest is allocated for storing. Okay, so this part is allocated for storing, but there are 2 pages allocated for a different purpose in the buffer frame. Okay, so the purpose is one frame is to take the input and the other frame is to give the output. So you can't use this for storing in any way. So when then for a question buffer frame dila calculations karaddi, you have to know B minus 2 is the number of pages which you can use for your question. That one thing you have to be very conscious about. So this amount of this, the one I have shown in green, that one is the page that you can use for your calculation. Okay, this is the page where you can store. So now in a block nested loop join, what happens is we are considering a set of pages at once. In in simple nested loop join, we are taking a record, and in page oriented nested loop join, we are taking a page. In block nested loop join, we are taking a collection of pages at once. That is as a block. That is why you call it as block nested loop join. It's taken as a block. So for each block, we are going to scan the inner table. That is the idea here. So initially what we did, for each row we scan the inner table, and the next one for each page we scan the inner table. Now for a set of pages means it's a block. For a block, we are going to scan the inner table. So here how to put the equation. So when we are going to read the blocks, we are reading every page. Somehow the outer table, every page is read. So that is M plus how many times is this N pages read? These N pages are read the number of blocks times. So number of blocks in M. Okay, this much of times the N page is read. Then make a baladi, we don't know how many blocks are there in M. But since they have given the buffer size and the number of pages, we can find the number of blocks. That is one thing we have to know to do. Okay, so I'll repeat. In block nested loop join, what happens is we are scanning the inner table for each block of the outer table. Okay, a block is a set of pages. Then මෙතන තියන්න පුළුවන් maximum number of block is from this number of pages. M number of pages only we can create the block because we have maximum M. So eventually we are reading all these pages. So M plus may inner table එක read වෙන්නේ this much of times, this block times. So N into number of blocks in M. So how to find the number of blocks in M? That is the next task. Okay, so here they have given the buffer size that is b minus 2. So the idea is then now to find the number of blocks, what you do is you divide the total number of pages in the outer table divided by the block size. Right? That is the idea here. Okay. And the seal value of that. Now I will show it with an example as well. So finally what the equation that you will get is m plus n into this much of blocks. The CL value of m divided by b minus 2. That will be your cost for the block nested loop. So for now have this idea in the mind. When I do the question, it will make sense. Okay, I will go with the question and then I think it will make sense. The next join is the index nested loop join. Now, I think yesterday everybody were there in Yasuru's session where he taught you about index. So what does the index do? It speeds up a process. Okay, so again, this is the outer table and this is the inner table. In index, what happens is for each page of the outer table, we go and read the index. For each record of the outer table, we go and read the index. Now, I'll give an example. දැන් මෙතන tables තියෙනවා M and N. M and N. කියමු දැන් N table එකේ there's an index. Okay, so inner table has an index. එතකොට what happens? There is another new index table created, right? So hope Yasuru has covered all this yesterday. You all have an idea about it. Now, without now before what we did is for each M page, we went and selected this inner table. Now, without going to the inner table, directly we are going and finding that thing from the index itself. It can be a hash index or B plus tree index. We are directly finding it from this index table and calculating the cost. So that's why when using an index, our cost will be less because අපිට දැන් මෙතන inner table එක search කරන්න ඕනේ නැහැ. ඒක index වලින් directly we can take. So that idea is only there in index nested loop join. So here let's calculate the cost. You have comma outer table එක fully scan කරනවා. So you have M plus the index cost. Index cost depends on the question. So in the question you have to pay attention whether it's a B plus tree index or a hash index. If it is a B plus tree index, right? You know B plus tree index is the tree structure. එතකොට B plus tree index කියද්දී ඒගොල්ලෝ height එක දීලා තියෙයි. The height is 2 or 3 or 4 they would have given. If it is not given, assume a height between 2 to 4. ඒ කියන්නේ ඔයාගේ calculation වල you mention the height assumed is 3. The height assumed is 2. Likewise, you have to give a assumed height. Then that into the number of records in the outer table. That's all what you do. What you do, you will scan all the pages. ඒ නිසා මේ M එක එනවා. And for each record of this outer table, you are going and finding අරක index එකේ තියනවාද කියලා. So index එක බලන්න ඕනේනේ. So for that you have an index cost. And for each record, you have an index cost. That is M into PR. PR is the records in the outer table. So this is the cost estimation for index nested loop join. Now, have this, grab the idea. When I do the question, you all will get more of what I meant. Okay, then the next one is, sort merge join. The next one is a sort merge join. What happens here is you have an outer table R and an inner table S. අපි මේ tables දෙකම sort කරනවා and then we are merging those together. We are sorting this table. We are sorting R table first, then sorting S table first, and then merging both together. That is what happens in sort merge join. Okay, so here if you see the cost, to sort this R table, there is a cost. So sort, there is a cost. And then to sort S, there is a cost. Sort S, there is a cost. And then finally we are merging both of these. So to merge this, there is a cost. Merge R and S, there is a cost. This is pretty simple. You have to sort R, sort S, and merge R and S. That's the equation for sort, merge, join. But when there's a question coming with sort, merge, join, also you have to pay attention. දැන් මෙතන sort කරන්නේ කොහොමද? Sort, now initially all what we found was M into PR into ඒක දීලා තියෙනවා. M number of pages, PR number of records, ඒ ඔක්කොම you will have it in the question. Only thing is you have to apply it. But in sort, merge, join, when you're going to sort R, you have to do another set of things to get this answer. You have to do another set of things to get this answer, and then finally you have to merge. So that I will explain it with the question itself. So before I go to a question, if you all have any doubts, if you want me to explain again any part, can I just put it in the chat? I hope nobody has any questions. Right. So here there is a small summary which I have written for myself. I'll just show it to you all so that you all can quickly go through. So what I told was there's a simple nested loop join. Simple nested loop join means you take a record of the outer table and scan the inner tables. So this is the cost for that. Record of the record again. Then from page oriented nested loop join, what you do is you take a page of the outer table. So this will be your cost. Okay. So sometimes you won't, they won't give you which is the outer table, which is the inner table. At that time when you're doing the question, you have to, then Hitamu, you have M table and S table. Then you have to take the M table as the outer table and do a calculation. Then take S table as the outer table and do the calculation. From both those, you have to decide which has the lesser cost. But there is one logic which you have to think. Normally, if there is a table which has lesser number of pages, we'll say M has 100 pages and N has 50 pages. From that hint, you have to identify your outer table is N. එතකොට outer table N කරගත්තොත් ඔයාගේ cost එක අඩුයි කියලා you have to understand. That is one thing. Because මෙතන addition එකක් නේ වෙන්නේ. So if the outer table, the pages are less, that means your cost will be less. So that is one hint. That means without doing both ways and checking, you can check like this. Check which table has the lesser number of pages. That will be your outer table. That is one thing. You can, like when it comes to MCQs and all, you can use that. Then the next one I told was block nested loop join. There we are taking a set of pages. Initially a record, then a page, now a set of pages. So to find a set of page, to say a set of pages is a block. Block එක හොයන්න you should know the buffer size. It would have been given the buffer size is 5 or 20 or something. But buffer size you should not take it as 20 itself. 20 minus 2. Why is that 2? One is to take the input, one is for the output. That also you should know. Sometimes there can be a buffer size given and they will ask the page එකට allocate වෙන buffer size එක කීයද කියලා. එතකොට if you say 20 itself, it's wrong. 20 minus 2, 18. Then this is the equation to find the number of blocks. That is the total number of pages divided by the size of one block. So for this you have to find the seal value. That means the higher value. You can get 5.6. You can't have a block like 5.6, no. So you find the seal value as 6. That's that block nested loop join. In index nested loop join, what happens is you're using an index. So AKIT, you have to pay attention whether it's a hash index or B plus tree index. And also when doing the question, I will explain. You have to also pay attention the alternatives. Alternative 1, the alternative 2 or alternative 3. That also you have to pay attention. That of course I'll explain with the question itself. So when it comes to the index nested loop join, index cost, that means outer table is scanned fully, and to for each index inside the index table we are scanning all the records. That is this equation. And then finally the sort merge join is sorting cost. Then කියමුකෝ there are 3-4 relations, employee, department, project, work ඒ වගේ query එකක් දීලා තිබ්බොත් you have 4 sorting costs: sorting employee, sorting department, sorting project, sorting work, plus merging all these 4 tables. That is what happens in sort, merge, join. So there is a question in our MCQs, the seniors MCQs. What are the join algorithms? ඒකෙදි simple nested loop join, page oriented nested loop join, and index nested, block nested, and sort merge join will be the answers. If they give external merge sort, that is an algorithm which we'll be studying in the coming time. So this is the basic algorithms which you should know. Now we'll directly go for a question. The question in the tute is actually a past paper question, so we'll refer that first. It will be easy. So we finished this, how to draw a query tree, relational algebra expression in a query tree. Then we'll go for the next one. Consider the join R and S given the following information. So here, when it comes to me, if I read this question, I will jot all this information in one place first. So here the important informations are: relation R contains 10,000 tuples and has 10 tuples per page. Then from this, what can you identify? You can identify how many pages are there. Totally 10,000 tuples තියනවලු, and one page has 10 tuples. So if you divide 10,000 by 10, you will find the number of pages. Likewise, relation S also contains 2,000 tuples and has 10 tuples per page. From this, I can divide 2,000 by 10 and identify the number of pages. So you can see nothing is given direct, but the data that are given will be useful to derive some things that we need. Okay, and both relations are stored as simple heap files, and they have also mentioned neither relation has an indexes built on it. So from this we have to know there is no index. Again, you don't want to think about B plus tree, hash index, alternatives, you don't need. And they have given the 52 buffer pages are available. So this is the another important data. So from this you have to know 52 dunna gaman you don't use 52, අපි use කරන්නේ 52 minus 2, that is 50. So then the questions are to find simple nested loop join, page oriented nested loop join, block nested loop join. So I will show you my answer. Okay, so hope you can see my answer now. So here the R table has 10,000 tuples and one page has 10 tuples. So I divided those and found the number of pages in R, the number of pages in S. And there is another important thing which I highlighted for myself, that is there is no indexes. And the buffer, there are 52 pages. Now the question is cost of simple nested loop join. So simple nested loop join කියවම we know simple nested loop join කියන්නේ it will take every record of the outer table and scan that with the inner table. So you know the number of pages. Now you actually know the equation as well. But don't memorize the equation, because එකක් හරි මාරු කරලා දුන්නොත් you can't figure out what to do. So don't have the equation in your mind, but know the concept as well. Okay, so you have 1,000 pages plus you are scanning 200 inner pages for this much of records. But now here you should have noticed we don't know which is the outer table and which is the inner table. We don't know that. So what we do when it comes to an essay question, you have to do both ways and say, can I take R as your outer table and do the equation, do the calculation, take S as the outer table and do the calculation. And now you will see for R, when R is the outer table, the cost is this much. And when S is the outer table, the cost is this much. Okay, from this you can identify this has the lesser cost. The optimizer will go for this plan. This plan is the best plan that it will go. Okay, but when it comes to an MCQ, you can't be doing both these. No, you have only a limited amount of time. So just see in R and S which has the lesser number of pages. R has 1000 pages, S has 200 pages. Confidently, you can take S as your outer table and R as your inner table and go for that answer, because obviously that is going to give you a lesser. So this is what I mentioned in the previous part when I taught you the theory. So yeah, I have written that as well. Having lesser pages in the outer table provides less IO. That is one thing you have to remember. Next one is a page. They have the question is a page-oriented nested loop join. So page-oriented nested loop join means what we will do is we will scan the outer table, the inner table for each page of the outer table. So same, you know the number of pages of the outer table, you know the pages, number of pages in the inner table. Just the matter of fitting the values for this equation. And here also you can directly do only this part, the S as the outer table, because why, you know S has a lesser number of pages, so then this answer, this will be less, so you can directly go for this one. Then the next question is block nested loop join for the same one. So block nested loop join means you have to know the number of blocks in the outer table. For the number of blocks in the outer table only, you're going to scan the inner table. So we know the number of pages in the outer table, that is 1000, plus buffer size was given, it's 52. And I told you buffer size means you can't use the whole size, you subtract 2 from that, only that amount of pages are used for our storing. So 1000 divided by 50, the CL value of that into the number of pages in the inner table. So finally you'll get this as the cost. So once you like revise it once, you can definitely remember this equation. So if it is very direct, use this equation, that's easy. Or else if you know the concept, if whatever they give, you can manipulate this equation in a way you want. Then the last question what we had was assuming that there exists a B plus tree index with height 3 on B column of relation S, what is the cost of performing an index nested loop join? Now until the C part, we didn't know which is the inner table and which is the outer table. But using this page count as a hint, we decided S is going to be the outer table and R is going to be the inner table. That's how we did. Now here in this index itself, they have given a hint. Okay. First thing you have to notice is it's a B plus tree index. So if it's a B plus tree index, your index cost will be between 2 to 4. But they have mentioned with height 3. Then obviously your index cost is going to be 3. If it is not given, you can choose 2, 3 or 4. And then they have said on B column of relation S. So when they say on B column of relation S, you have to identify normally the index we apply to the inner table to exploit the. So normally if they say on B column of relation S, take the S as your inner table. Simple. And then find the index nested nested loops cost. So here, let me show my answer again. So here B plus tree index on B column of relation S. So directly without any problem, I have taken the S as the inner table. So if S is the inner table, R equijoin is. That is my equation. Index nested loop join means we are scanning all the pages of the outer table, and with for each record of the outer table, we are scanning the index. So this is the answer for that one, 3 into this. But now in this question, they have not given us whether it's alternative 1, alternative 2 or alternative 3. Now, I think from yesterday's session, you all clearly know what is alternative 1, 2 and 3. Alternative 1 means the record and the index is in the same place. You don't need to go take the index and find the record again. You have both at the same place. But if it's alternative 2 and alternative 3, you know the idea is the record is found separately and the index is found separately. Let me share that as well. Right. So alternative 1 means you if you find this index ආය කොහෙවත් යන්න ඕනේ නැහැ ඔක්කොම තියෙන්නේ මෙතනමයි. So you don't need to go anywhere. I'm talking about a b plus tree index which is of alternative 1. Okay, then if there is a alternative 2, say you locate this one, for this one you have an RID. From that you have to go and search, you have to locate that record in the table. And if it's alternative 3 also, you have an RID list, and from that you have to search in this table. Okay, so according to our equation, going to this index is only 3. The index cost is 3. Again, now you have a b plus 3 index means it's coming like this now. And you know, only the leaf level has all the values. I hope all those parts are clear for you all. Only the leaf parts have values. So if I assume I am using alternative 1, if I come and locate this place, that means fine. I got the value. Alternative 1 means index thiyena thanamai. The record is also there. I don't need to go anywhere. So I directly take the cost as 3. But assume this is alternative 2. If it's alternative 2, you don't have the actual value. What you go and check, you get is the index and the RID, the key value. With this RID, again you have to go to the table and go to the table in the sense you have to go to the leaf level and fetch the result when it's alternative 2. So then there is an additional cost for that. Okay, so this is another thing that you should keep in mind. When they say when they say index, first thing you have to check is where that index is. So from that you can decide what is the inner table and what is the outer. The second point is the index a b plus 3 index or a hash index? If it's a hash index, the cost is going to be 1.2. And if it's a b plus 3 index, the cost is going to be 2 to 4. That is the second thing. And the next thing you have to think is what is the alternative? Is it alternative 1, 2 or 3? If it's alternative 1, fine, you can just use the cost. Then b plus 3 means it's 3. Hash means it's 1.2. Directly you can use. But if it is alternative 2, you have alternative 3, you have to add the 1. Why? Because the record is not there in that index place itself. You have to go to another position again. There's another switch taking place. So you have to add another 1. That is the other thing you have to keep in mind. So according to the tute question we did, it's not given. There is nothing given saying it's alternative 1, 2 or 3. So here when we are doing it, we have assumed it as alternative 1. Normally if nothing is given, assume it as alternative 1 and 2. But remember, if you are not using alternative 1, if alternative 2 or 3 is mentioned, it is not only 3, it's 3 plus. For hash index also, it's not only 1.2, it's 1.2 plus 1. That part you have to remember. So this is about the until index nested loop join. I hope it's clear now with these questions. If you have any doubts, if you want me to explain again, just drop a message. I will explain it again as well. Part D, that is the index. Okay. Now they have asked an index nested loop join. So you know, if it's an index nested loop join, what we are going to do is we are going to scan the outer table. Let me draw it and show. If it's the index nested loop join, there is M and there is N. So what we are going to do is we are going to scan the outer table, and for each record of the outer table, we are not going through the inner table because this inner table already has an index. They have said there's an index. So directly for each record, we are going and checking the index because index is sorted and it will increase the searching speed. That you would have learnt it yesterday. So that is why for each record, the scanning time for N is not there. Directly you are going and fetching it from the index table. You use the S table as the inner table. Yes. Okay, I'll explain all those. Now here I'll go back to the question again and I'll point some stuff. In D part, first thing that you have to notice is they have said B plus 3 index. Okay, from that you have to get the idea. The cost is going to be 2 to 4. Okay, and then they have mentioned on B column of relation S. So here they have said the index is on the B column of relation S. This is the hint I got to decide S is the inner table. Okay, so that's there in the slide as well. I'll show it. Normally, when they say an index is given on B column of relation S, you take that table as the inner table, right? And then what is the cost of forming an index nested loop join? So now from this you know B plus tree and the height is given and you know from which table. But one thing that is not given here is what is the alternative? Alternative 1, 2 or 3. Because it's not given, I am assuming it has alternative 1. So with that I'll go. So index nested loop join means what happens for every record of the outer table we are searching the inner table. So that is M plus the index cost into every record of the outer table. This is the basic idea of the index nested loop join. So since I am assuming it as alternative 1, I know the index and the record I need is in the same place. So I don't need to go take the index RID and go anywhere. It's in the same place. So if this is a B plus tree with height 3, then it's 3 itself. But if the alternative is not 1 and it's 2 or 3, that means you have to take the RID and go for another place to fetch it, right? That fetch, you add 1 for that when it is not alternative 1. Normally you will get, it won't be mentioned as alternative 1, 2, 3. At that time you use alternative 1. But if it is mentioned, please remember that you have to add this one. So hope that is clear now. How I took the inner table and the cost. Okay. So before we go for the sort merge join, I have to teach you another algorithm, that is the external merge sort algorithm. From that only we are going to do the sort merge join. Okay, so I will show that with an example. Okay, so hope the screen is visible now. Yes. Now now we are going to discuss about external merge sort algorithm. So here, please keep in mind, I'm talking about external merge sort algorithm. It's not a join algorithm. So if in an MCQ, if they say you to choose what are the join algorithms and they give you external merge sort algorithm as well. External merge sort algorithm, it is not an answer. Sort merge join is a joining algorithm, but not external merge sort. It's a sorting algorithm. This I'm using to sort, just to sort. Okay, so hope that one is also clear now. So I will go for the example. Imagine I have a table, a data file, a table in the sense a data file which has 108 pages. Okay, so there are I have just showed 10 pages here, 108 pages, and they have mentioned there is a buffer which has 5 frames. There's a buffer which has 5 frames. Now our motive here is we have 108 pages. We are going to sort this and get one file. This is our ultimate goal when we are going to do the external merge sort algorithm. We are going to sort all the pages and get one file. So let's see how to do that. Now they have given the buffer is 5 frames. So when it comes to an external merge sort algorithm, there are 2 steps. Okay. The first step is you sort. First step is sorting and the second step is merging. I'll explain why you have to merge. Okay. Now initially you have a buffer with 5 frame. Now you have 108 pages, but you have only 5 pages in the buffer. So that is obvious. You can't read all the 108 pages together. No, you have to read 5 by 5. So initially the first time I'm taking
Settings.
is there a question? Is there a question from someone?
No.
All right. So it's obvious I can't take all 108 pages at once and go to this buffer. No, there are only 5 frames that I can read at once. So what I'll do, I'll take 5 by 5. Okay, so I'm taking the first 5, taking it here and fitting it into memory and sorting it. And then this is the first file I'm getting. Okay, then I'm taking the next 5 pages, fitting it into the buffer frame and getting the next file which has size 5. Okay, likewise I'm sorting these 108 pages each 5 by 5. So from this you have to identify how many files will come at the end. Now when I take the first file, I'm getting 1 file. The second 5 pages, I'm getting the second file. Likewise, to sort all the 108 pages, once I sort it and finish, 108 divided by 5, that is I think it's 21.6. So 21.6 means it's like 21 and another half of a file is being there, is added there. So I can't ignore that. So I'm getting a CL value and there are 22 files that I'm getting. If I sort all these 108 pages, at the end I'm getting 22 files. But my aim here is to sort all these 108 pages to get just one file. Okay, so that's why without stopping with sorting, I'm going for a merging where I have to merge all these 22 files together to result one file. Okay, so that is the idea here. Get it correctly. You get 108 pages and my motive is to sort all these pages and get one file. But since the buffer frames are only 5, now it is not always 5. There can be 20 buffer frames, 19 buffer frames. It depends on the question. For example, I have taken it as 5. Since I have only 5 buffer frames, I can't sort all these 108 pages at once. So I'm taking 5 by 5 and sorting. But when I take 5 by 5, instead of getting one file, I'm getting 22 files. Now I have another work. I have to sort these 22 files until I get one file. For that, I'm doing the merge step. Okay, that is the idea here. So I'll demonstrate it and show. That is the basic idea. What I'm going to do now. Okay, so now we know there are 22 files, each of size 5. Now what we are going to do is we are going to fit each of these file into the buffer frame. And one thing that you have to remember is this this one frame cannot be used. Okay, it is used for the output purpose. This is reserved for output purpose. So I have only 4 frames now. When sorting, I'm not sending out anything now, so I'm using all these 5 frames to sort it. Okay, but when I'm finally when I need to merge everything, after I merge, now say I'm merging this file and this file, then this file and think there is 2, 4, 5, 3 and 1, 9 maybe. So when I sort both these together, what I will get is 1, 2, 3, 4, 5, 9. A file like this, no, to put this output, I am reserving 1 frame here. Okay, so whenever you have 5 frames, you can't use 1 frame because 1 frame is you can't use 1 frame for merging here because 1 frame is used to get the output. That is another thing you have to remember. So now we'll go for the merging. So now there are here there were separate pages and I took each page at once. Now I took this page, likewise I took and merged. Now I have separate files like that. So what I'm doing is I'm taking this file, then the second file, and say I have another file, third file, fourth file. So all these 4 files I'm merging. Okay, that is the second step I'm doing. So what am I doing? I'm taking from 22 files, I'm allocating it for 4 frames. That is what I'm doing as a second step. That means now if they say you have 5 frames, you can do only for 4 frames. If they say you have 20 frames, you can do only for 19 frames. So this denominator depends on that, the number of frames that you can allocate, right? So at one time, now here how many files I can merge? That is only 4 files I can merge. So that's what I have taken 4 here. How many files I have to merge? That is 22. So that is why I have taken 22 divided by 4. Then finally when I divide this, I'm going to get 5.5, which means 5 files and another half of the file is merged. So I can't ignore it. So I'm taking the seal value. Now I'm getting 6 files. 6 files are merged now. But still my aim is to get 1 file. So what do I do? The third step, 6 divided by, again now here I have 4 frames now, 6 divided by 4. So when I divide it like that, I'm going to get 1.5, which is 2 files. Still not enough. Now one thing you have to notice, say 2 files are there. Think this is 1 file. I'll show it in another color. This is that 1 file, final 1 file, and this is the final other file. Now to merge these two, I need only 2 frames, right? These 2 frames I don't want, but I need 1 more frame to put the output. So to merge 2 files, how many frames I need? I need only 3 frames. So the last step is 2 divided by 3, not 4. Even though there is an extra one, I don't need it. I don't use it. So that is why I'm taking this 2 divided by 3. That is finally 0 point something and a seal value 1 file is resulting. I will explain this again. It might be confusing. So I'll explain this again. There is a table with pages. Okay, say I have 108 pages for an example, and the buffer frames given are 1, 2, 3, 5, and I told you the outer one is booked. Why? Once you sort everything to get the final output, you need 1 frame. So this is booked. So only 4 frames are available. So initially my aim is to convert this 108 pages. I'm going to sort it into 1 file. I need 1 file. So in the sorting process, since I have only initially to sort I have 5 places. So we take it as passes. In the database view, we take it as passes. Okay. So what happens? 0 is you take 108 pages and take 5 by 5 and fit it into memory. First page, second page, third page, fourth page, fifth page. Then comes 1 file. Then take the 6th page, 7th page, 8th page, 9th page, 10th page. Then comes the second file. Likewise, 5 by 5 I did, and finally I'm getting 22 files here. But I can't stop from here. Why? My final aim is to go for pass 1. Pass 1, only pass 0 is sorting. Okay, pass 0 is only sorting. From pass 1 onwards, it's merging. You sorted and got the 22 files. Now what you have to do is you have to merge 22 by 22, 22, and you finally have to get 1 file. So in the pass 1, what happens is, I told you the last one is allocated for an output. So you're getting 22 divided by 4 seal value. Then you will get 6 files. Likewise, pass 2, you have 6 files and 4 frames. You get the seal value, and the value will be 2 sorted files. That means you will get decimals. You can't stop it you can't keep a file as half. So you will get a seal value. Then Finally, in the past 3, what happens is I have only 2 files. Like this, I have only 2 files, but I have 4 frames. I have 5 frames here now. So this file will set here. This file will set here. This I know this is extra. This is extra, and this I need to put the output. So I need 1, 2, and 3 pages only. So that's why finally I'm taking 2 divided by 3. And finally you'll get 0.66. So that is one sorted file. My aim is done. So I stop it from here. So how many passes I have done is 1, 2, 3, 4 passes. So this is the sorting algorithm. Is that part clear? Or you all have any doubts? I hope nobody has a doubt. Okay. So why I taught this is for the sort merge join. Sort merge join, you have to find the sorting cost now. Now I'll take the same example. R is the outer table and S is the inner table. Sorting R plus sorting S plus merging both. You need this. So for this part, you need that algorithm I told. Okay. Think that sorting R was that 108 pages file that I told. So you will find the number of passes. Here you the number of passes. From here you found the number of passes. So the sorting cost, how you can find is, let me erase this, it's a mess. So remember there are 4 passes. Finally, to achieve our aim, there are 4 passes. So to find the cost of external for one sort, what you have to do is you need the number of passes times the number of pages times 2. I'll explain why is this 2 and the number of pages. Now in pass 0, what happened is you're reading all these 108 pages. Okay, you're reading it 108 pages and then you're getting 22 files. You're writing it to the database. So in pass 0, you're reading 108 pages and you're writing it to the database. So read, write, both are happening 108 times. Then in pass 1 also, even though you're reading 22 files, in that 22 files, what do you have? We still have that 108 pages. So in the pass 1 also, we are reading 108 pages and writing 108 pages. In pass 2 also, even though it reduces 6 files, that 6 files have 108 pages. So you are reading 108 pages and writing 108 pages. Pass 3 also the same. So read, write, the same number of pages is happening. So that is, this 2 times is, 1 is for read and 1 is for write, and the number of pages, how many times it's done, that is the number of passes. So this is the idea between external merge sort algorithm. To find a sorting cost, you have to take the number of pages and sort it. You know the buffer size, then you will sort it and until you get one file. Once you sort it, you will find how many number of passes are there. Each pass, you are reading and writing the number of pages. So that's why I have put this 2, read into write, into the number of pages, into the number of passes. That is the sorting cost. Where is this used? It's used in that sort merge join algorithm. In this part, when they give like this, you have to sort the R table using that external merge sort algorithm and get that answer. Say, let's just think it's 800 something, 800 plus. Then when coming to sort S, how many number of pages are there? I think there is 10,000 pages in S. Go back to 10,000 and do the sorting algorithm and find the cost and come back here and add that cost. Plus, to merge both, say R has 100 pages, S has 10,000 pages. You have to merge both, no? So 10 plus this much. This will be a final sort, merge, join cost. So to find the sort, merge, join cost, you should know this external merge sort algorithm, but it's just a sorting algorithm and it's not a joining algorithm. Is that part clear? Okay. I hope it's clear for everyone. Oh, I don't know if it's unclear. If it's not clear, please drop a message in the chat. I can explain it again. Okay, because I'm running out of time, I'll quickly go through some questions. First of all, some questions related to what I did now. I'll go through that. So if you see this question, what are the passes count and cost of 5 buffer pages and 112 page file in external merge sort? Now this is what I did previously. So from this, what you have to point out, the things you have to understand is there are 112 pages and there are 5 buffer pages. The question is what are the passes count? So let me go and do that. Okay, so here the question was the buffer frames given are 5, it seems, and the pages that that they have is 112, and the question is the number of passes. Number of passes is the question. So we know the first step is the pass 0 is always a sorting, and the other passes, maybe pass 1, pass 2, pass 3, all those are going to be merging. This part we know. So to sort, we are using all the buffer frames. So what we are going to do, simple, write pass 0, 112 divided by 5 and the seal value of that. Why? You can't leave a file in half. So from that, I think you will get 23 files. Okay, but our aim is to get one file. We can't stop at 23. So go for pass 1. But now here, from here onwards, sort is over. The next is a merge. Pass 1, you take 23 files and you have 5 buffer frames. But can you use all 5? No, you can only use the 4. So 23 divided by 4. That you'll get 6 files, right? And then now still one file is not there still, so go for pass 2. 6 divided by 4, the seal value of it, you'll get 2 files. Now here you should be careful, you can't be using 4 everywhere. Now you have to get the logic. You have 2 files to sort. You have only 2 files to sort. That means you need this place, you need this place, the 2 slots you need, this place, and you need one more slot to put the output. So you need only 3 slots. So you take 2 divided by 3 and the seal value. So it results in 0.66. That is, one file is there. So the answer, how many passes? 1, you add the 0 as 1. So you have 1, 2, 3 and 4. So the answer is 4 passes. So in case they ask what is the cost here, what you will do is 2 into the number of pages is 112 into the number of passes. So this will be your cost. That is 896. So That is like, if you get a proper practice, it's like a 2 minute question. So like this question, we have about 4 or 5 questions in our seniors ones. So maybe we might also get some questions like that. Let me show another question also. So in this question also, assume you have 5 buffer pages to sort 72 page files. Calculate the cost. It's the same, eventually the same. And here, what is a not table joining algorithms in query processing? Page oriented, index nested, block nested, simple nested. But here, external merge sort algorithm. This is sorting algorithm. It's not a table joining algorithm. So that is what I mentioned before. And then if you see this question is assume you have 9 buffer pages sort in a file. And then how many passes we get in external. So here the difference is you have 9 buffer pages. I will show that as well. There you can identify the logic what I told. The question is you have 9 buffer pages and there are 120 pages. They're asking the number of passes. So if I do that, so there are 120 pages, and now here the buffer page is not 5, it's 9. 1, 2. You have 9 buffer pages. Pardon my handwriting. If it's not clear, please let me know. So there are 120 pages and there are 9 buffer pages. So initial pass 0, what we will do is we are going to sort it. So 120 divided by 9. We are using all 9. This thing you have to remember. We are using all 9 here. So at this point you are getting 14 files. Okay, so we have to go for a merge. So we are taking these 14 files, and now you can't use 9. Why? That 1 is needed for the output. So 9 minus 1, 8. We are taking only 8, and there are 2 files now. But still you can't stop because we need only 1 file. So go for pass 2. Now here we need only 2 files. So this slot, and 1 slot for the output. So you have to go for 2 divided by 3, not 8. Not 8 here. If you put 8 here, maybe the answer might be correct, but the way of logic is wrong. So anyway, 2 divided by 8 is also going to be some 1 file, but your logic is wrong. So the number of passes is 1, 2 and 3. If they ask the cost, 2 into 120 into 3. This is your final cost. Here why I have used 2 into 120 is for each pass I am reading and writing 120 pages. Reading 120 pages, writing 120 pages. Here also I am reading 120 pages and writing. So that is why I have used that. So yes, that's all about external merge sort algorithm and sort merge join. Now since we don't have enough time, the other lessons are to be done. I have done the tutorial 8 also, which has this sort merge join and stuff. I'll share it with you all the explanations are given in that itself. So you can check it, and if you all have any problem, you can ask me later. Okay, one question I'll discuss which is important. In tutorial 8, the third question, consider the join of two relations R and S which contains 20,000 tuples and has 10 tuples per page. S contains 1,000 tuples with 10 tuples per page. So I told you they will give you the tuples. From that you have to identify the number of pages. But the thing that you have to check here is assume that there are clustered B plus tree indexes on R and S. Now, so far what we did, there was no indexes. We just found the sorting cost. When it comes to sort merge join, we just found sorting cost and added. Now here when it comes to the index, they have asked the sort merge join of R and S. So when there is an index, we already know the index is already sorting that particular table. Okay, so here there is a index in both R and S table, which means R and S are already sorted. You don't have to use the external sort merge join algorithm and sort it. So at that point, you can just say 0. Sort R is 0, sort S is 0. To merge, you need 2000 plus 100 pages. That is your answer. So when you get a sort merge join, don't like start going for the external merge sort algorithm and sorting. If there's an index, just think. Sometimes there can be an index only in R and not in S. Then you have to sort S but not R. So there are things like that. So imagine in this place there is no index. That means we should sort R and S now. That part I have done. Because the buffer frames are not given here, I have assumed the buffer frames as 5. But otherwise, normally the buffer frames will be given to you. So one thing to remember is in the past when sorting, you have to take all the number of buffer frames. When you are merging, eventually you will take only buffer frame minus 1. That is B minus 1 way merging. And in the last step, you have to think about the file and get the if there's 3 files in pass 5, then you're going to take 4 buffer frames. Why? You need 3 to merge and 1 to give output. Likewise, this last pass you always have to think and put it. So now I have assumed so R and S are not having an index, and I have sorted both R and S and found the cost of the sort merge join. That is also one important thing. So yeah, the rest of course I have done with proper methods. I will share it with you all because there is not enough time. You all can go through that. So do you all have any doubts in whatever I did? You all want me to repeat anything? If there is no doubts, we can wrap up this session now.
If anyone has doubts, you all can put it in the chat and then Kovisha can reply. We'll take like a 5 or 10-minute break and start with transaction and concurrency control. How much of a break do you all need? Is 5 minutes enough for 10 minutes? කවුරු හරි කියන්න බෑ. විනාඩි 5ක් ඇතුළත නැත්නම් 10ක් අරන් යනවද?